Hello. Do you hear me okay? Just give it a second here.
Hi, Vijay. Good morning.
Hey, good morning. How's it going?
I flew to Toronto last night, so just getting up for the day.
Oh, okay. All right. Let me go ahead and get my screen share going. Hey there, good morning, Srini. Good to see you. I'm just getting back to the pages we were on. And then I'm also just making sure that people can get in. Sometimes people will like message and say, oh, I can't get in, I can't get in. So I'm just seeing right now who's coming through the participants. Okay. Do you know if Amelia is coming, either one of you?
No, I have no idea.
Okay, that's all right. Okay, well then I guess we'll go ahead and start. I think last time we ended up on talking about history, and we talked about how data went from being like JSON documents to basically relational in nature when there was more than one relationship. And then finally, we started looking at graphs. And so now we're just kind of in this section about history. And so we talked a little bit about hierarchical models and relational models and then network models. And there was a little bit of information here about, where I've highlighted, I talked a little bit about the codicil, which is, Conference on Data System Languages. This is kind of like the first network model that came out. By the way, good to see you, Amelia.
Vijay, can you make this window full screen?
Sure.
Okay.
Is this easier for you to see?
Yeah.
Okay. Do you want me to increase the font as well?
Yeah, that would be great.
Okay. Is this better?
Yeah, much better.
Okay. All right. So again, yeah, just talking about how we got to history, like because document databases, this was kind of a question in the book, is the stuff that we see with MongoDB currently, is that something that's repeating history? Because we already had it in the 70s. We had something similar to JSON, which was called a hierarchical model. And then it eventually started to become limited. And so people tried to improve this, and that became what we know as SQL today, relational model, as well as the network model. Both of these ideas kind of came around the 70s as well. And they competed against each other, but I guess SQL kind of won greater acceptance. That's kind of like what history says. And the reason is because codicil, which was the network model, which, eventually is today's graph model, that basically at that time was a little bit, it was a little bit cumbersome in terms of implementation and like usage. The thing about codicil, right, which you can think of as the network model back then, basically it was sort of like the hierarchical model in that every record has one parent and you have like nested parents or nested children. And this was something that kind of allowed many relationships to be able to be modeled. But then, going down that track, I guess, it became a little bit difficult to navigate. And they kind of say like a query in codicil is performed by moving your cursor through databases, by iterating over lists of records and following access paths. If this record had multiple parents, the application code had to keep track of all those various relationships. And so this was very difficult, especially if you have tons of parents in an n-dimensional data space. So that was sort of a problem with codicil. That's kind of like what I was thinking about, as far as like the history point that they're trying to make. Back then, there were n possible dimensions. And then also, they were using things like tape drives. And that wasn't very fast, in terms of like what we have today. I see you have your hand raised. Amelia, what's up?
Yeah, no, so I was wondering like what exactly is the problem they're saying. So basically, the problem they're trying to solve is trying to come up with an alternative way of representing data that has relations, right? Like if you have a region, for example, and and you want to model people living in a region. So in the network model, what you would do is there will be a record for a region, and then all the people living in that region will point to that record, right? Like that's
That's
you can
right.
path towards that. So they hit a problem. It did not scale because they say there are every time something is something is updated, right? Like you have to keep track of the access path, so you appropriately update them. Is that what you're saying? I mean, I didn't understand the.
Yeah, you got it. I think you
To,
do have it, the understanding. Go ahead.
yeah, to simplify your understanding, right, Amulya? So if you look at hierarchical model, right? So it's a single parent model. It's like a JSON blob, right? So you have a single parent, and all the data that you require is collocated. But there are use cases. Even in that, there were use cases where one document has a relationship with another document. So these two documents, imagine they are hierarchical models, right? Now you need to build a relationship because there is a use case that exists, right? Then they went with a network model, where in network model, they tried to design relationships in the hierarchical model, which is called network model, right?
Yeah.
So not just one single parent, you can have one entity can have, or one field can have multiple parents as well, because of the real world use case. So they try to implement relational model in a hierarchical model, right? That is called a network model. So now that's good. It solved their immediate problem, right? But now what happened with that network model is, now you because at that time the hardware was not efficient and the seeks and writes are very slow, right? So they have to manually remember this access paths, either when you're doing hand coding queries or within the code. So within the code, you remember those access path in memory, and then you reiterate and you do all this logic, right? So it became complex. So now the database is supposed to do the job. Now indirectly the application code is doing that job, right? The whole business logic is on the application side, and this has become very complicated. Even fetching might be easy, you write it once, but updating will also be difficult, right? Because read use cases are different from write use cases. So it become very complicated for them to manage the relationship in network model.
Yeah, I still don't, I'm not very clear on what they said. You have to remember the access path in the head. So I would imagine how they would have implemented it, right? Like probably there's
I'll
some...
give you an example, right? If you look at it here, there is no foreign key in the network model. So in place of foreign key, they used a pointer. So for example, you have a record, right? Which has a linkage with another record in another table, right? So now in a relational model, you use a foreign key, right? But here they've used a pointer. You have to remember that pointer and you have to follow that access path, right? You'll get the first address of that next record. Now you keep this one in memory and you follow that one. Now in that record also, you might have another pointer which is pointing to another record. So you have to keep remembering this one. So you have to remember all these access points based on this pointer. That is on the application side. Or if it is not on the application side, if you're using just a SQL-like kind of query client, right? So you have to remember this and you have to query and get the data.
Got it. Mm-hmm.
Whether it's application side, it has to be in memory. But if you're doing hand coding queries, then you have to remember this and follow that.
Mm-hmm.
That's what they meant in head.
Mm-hmm. Mm-hmm.
Awesome.
Yeah.
That's a great explanation. So let's move on to the next page here. Let's see here, just make sure. Yeah, so you can see like issues with codicil in the network model in the early days. So this is probably why like the relationship or the relational model caught on. And just like you're saying that you have difficulty tracking pointers in the codicil or network model. In the relationship model, you have the foreign key, which is kind of like the reason that this is a little bit better, right? And I think this is probably why, like, you know, people wanted to adopt to SQL as well, right? Even initially too, like people didn't really like SQL, but I think this is the one that sort of caught on. But it says that, you know, in the relational model, right, it's a collection of tuples or rows. And if you want to access data, you don't have access paths, right? It's like the opposite in some ways of the network model. You just read pretty much like what you think of Excel today, right? It's just rows in a table, and then you select information that match your condition, right? And you probably remember like the select calls from SQL. I think any people here who have done SQL programming would know that. So you also can insert a new row into any table without worrying about like foreign key relationships. But here's where I kind of like highlighted, I said that in a relation database, like the query optimizer, which is the thing that kind of hides, you know, the complexity from you, right, of searching for data. That's like your, you know, like your plain English statements, like select, you know, this column and this column and this column from table, you know, users, right? When you send that sentence over to something like SQL, behind the scenes, the query optimizer goes and figures out what the access path is and how it's going to like bring you back all this data. But it's kind of like a nice layer in that you can just kind of give sort of like a declaration of what you want and let the optimizer figure out the best way for it to return back that data to you. So you know, so I think this was kind of like the big takeaway that I took from this particular section. You don't really need to worry about the optimizer because that's handled for you by, you know, the like by the people who makes, you know, SQL from Oracle, but or even like, you know, the way SQL is like done for open source. Let's see here. Does anybody want to add anything like from this section that they got out of here?
Yeah. So
Yeah.
Go ahead. Yeah.
Yeah. Go. No. Go ahead, Amelia.
No, I was you say the text says that if you have new use cases where you have to query your data in new ways, then they say you declare a new index, right? So that's precisely what we do in our document DB. I mean, the idea is same. So if you have a use case, so the primary use case for writing the table might be one, but then you later come up with an alternate way of because it's very inefficient to query on keys that are not hash, the primary keys. So yeah, the way around is to actually write a new index, which is a copy of the table. So that's exactly what we do with SQL as well, I guess, right? So the idea is same in document DB also. So yeah.
Yeah. So I mean, the indexing is a very common pattern in any database that you take. It's what indexes does is it will store all these memory address, all these hard disk addresses in memory, so that it's fast to retrieve, right? What I want to add here is, if you look at the evolution itself, right? There was a problem, and they created a solution based upon the understanding they had the problem, right? And again, they got the new problem. They tried to invent a new model, hierarchical network model. So in hierarchical, they didn't find any relationship. They want co-location. And they will move the network model. Oh, they find a relationship, right? So they created a new model, but that model was not sustainable, and it's not easy to, it's not sustainable, and at the same time, it's also it is also not usable for all the use cases. It became complicated to be. And then they moved to relational model, right? SQLs, RDBMS things. But if you look at the path, right? As they learned the complexity of managing these models in relational, what they did is they moved all the complexity on the server side, which is on the database side. So that complexity is taken by query optimizer. So here, if you look at it, it's became like it was earlier. They thought it was declarative, but it was not declarative. It was imperative, because they have to do a lot of logic to get the right data.
Yeah.
But when they moved to SQL, it became declarative. So you tell what you need, but you don't tell the SQL server how to get the data. That is the job of query optimizer. Even if you do indexing as well, right? Query optimizer knows whether to fetch the data from the hard disk or to the indexing. But you need to tell, I mean, at least you have to tell what is the recurring read patterns or your access patterns, right? So that it will store in memory, but you don't need to tell it whether to fetch it from the index or fetch it from the hard disk. So that is the job of query optimizer. So all these experiences from the hierarchical model and network model, they have taken that word and put it in query optimizer. This is in years of experience. So I think this is one of the technologies has not deprecated, or we didn't still see not a use of it is relational.
Yeah, perfect. Yeah, and I think this is why SQL still is so dominant even today, right? Like, in terms of like when people think of how to save their data, SQL sort of comes to mind. We do have MongoDB, which is document coming back. But I think like this is like easier for people to work with. I think that's kind of like key, right? You write in a declarative way and then let an optimizer handle, how you want to get that data back. So it's easy to pick up for people.
I feel like when you are in a confusion to decide which database to design, I would say blindly go with relational. As you learn your data patterns, then you take what is the right model, whether it's document DB or graph or any other model.
Exactly.
Because it's easy, because but intuitively as humans, we know that there will be relations, but we don't know how frequent those relations will be and how loosely or how tightly coupled. If they are tightly coupled, it's better to go with the document DB. So you can learn from that. Even when we take the decisions, those decisions should not be final, right? They should be on the path of evolution.
No, but
Good
like
job.
I think you can. I think that statement is loaded, right? Like blindly go with relational, because like in this micro service architecture kind of, right? At least the data that you need. Like for example, if you have a service that only handles profiles, right? Like user identity management. The use case is pretty
Evident, right? For a document, if you don't know, that's what I said. If you really don't know the access model and you don't know the future of your evolution of your data model, it's better to go the SQL. But if you know your data model, your access patterns, and your relationships, right, then you'll have it will be pretty clear for you what is the decision that you need to take.
Yeah.
So this next section here just basically talks about the foreign key as the big differentiator between relational and hierarchical. It just says that, in many-to-many relationships, relational and document databases are not fundamentally different. The related item is referenced by a unique identifier, which is called a foreign key in the relational model, and a document reference or the document model. This identifier is used anytime you need to make a join or a follow-up query. So I think people kind of know about joins as well in SQL and how that helps make it easier to find data in the relationship model. You can kind of do it again, you can kind of emulate it with, JSON documents today. But in the end, I think that relational model is probably more suited towards this foreign key principle. Let's see here. There's another thing that if I go to the next page here, they talk about fault tolerance. Is anybody here familiar with that term?
Yeah.
Okay. Does anyone want to say what that means?
Yeah, sure. So basically for DB, right, there is a lot of the top reliability is the topmost requirement, right? Like the data has to be safe. I mean, consistency can be traded, but like reliability, the assurance that the data saved is remain safe in the somewhere in the even if the disk died or there is some power outage or something. So the data that you have written, there must be a guarantee for the customer to believe that the writes they have done are accurate. So so I guess for the DBs, the way they would implement that is I think the first chapter they mentioned about get the name. So it is a way to kind of write across the disks and kind of reduce the chance of a disk failure causing a complete failure of the operation. So basically you at a no-op level, right, the way to achieve fault tolerance is to kind of duplicate the writes, so kind of have backups. So that's one way. What else is suggested in here?
I think one more way typically people do is they have a write ahead log. So before the write completes, the actual operation of write is captured in a persistable log. And if the system goes down before the write is complete, they'll be able to replay the operations from the log and get the values in the database.
Yeah, basically correct. I was going to also add, it goes into this idea of ACID, where, I think, and I can bring that up here actually. They want to, I think this is a principle that SQL follows. Let's see here. So essentially that, let's see. Basically, it's called atomic, consistent, isolation, and durable. So transactions acting on several pieces of information complete only if pieces successfully save, right? This is part of the whole fault tolerance ACID principle. Mm-hmm. Here, all or nothing applies to the transaction. So if the transaction fails, exactly, they're going to try again later. But they're not going to do partial saves or anything like that. Then the data must be consistent. The saved data cannot violate the integrity of the database or the way the database is framed, like the schema. Isolation, no other transactions can take place and affect the transaction in question. So this prevents any kind of mid-air collisions or collisions in general. And then finally, if a system failure or a restart happens, we don't commit those transactions. So, and then these are examples of why you would want this kind of ACID database. Well, you don't want to like duplicate money withdrawals or duplicate depositing of funds, or it's really important for things like banking. So I just wanted to add that in here. I see we have a comment. Okay, cool. So you guys step away. So I think that's kind of like a key with, you know, like when you hear about SQL and stuff, when they market it, they say we're ACID compliant, we're fault tolerance, we've got concurrency. So so that's why people like SQL. And then there's also, you know, that schema is very, very important to SQL. Where I highlighted again, though, is that in the document database approach, you don't have to worry so much about schema, right? Like, and that's what MongoDB will kind of like market to people, is like, oh, well, you know, yes, you get more stricter, you know, relationships in your SQL, but you know, with us, you don't have to worry so much about like that strictness. You can kind of just throw in some data and you get that data faster. It's easier to replicate across like shards, and it's more local to your application. So you can do that work in your application itself. That's kind of like what I was highlighting here. So I think we kind of were asking this question. I pop in my head sometimes like on the WhatsApp as well. So I saw that people were asking about like what data model leads to the simpler application code, or like which one's the better one. So it says basically, you know, if you have one-to-many relationships, then it's probably a good idea to document, use document model like JSON. And then if, you know, it starts getting cumbersome, then, you know, you may want to switch over to like sort of relationships as a better idea, or for your thing, for your application. So, and they kind of tell you here, right? Like the document model has limitations.
I like to add,
Mhm.
yeah, I like to add one point here, right, on the author's comment about the simpler application code, right?
Mhm.
I'm not sure when this book was created, in which year, right? But if you look at it, I think we discussed even in this book, right, the maturity of ORM models. This will be a true statement if you're really managing multiple tables and doing joins from your application code, right? But with the advent of ORM, even that much of a burden is also taken care by another middle layer, which is ORM. So it is hiding all those abstractions. Today, if I have to write some CRUD operations in Java, I just need to write one single line of code because of the maturity of both ORM framework and as well as this, you know, the Spring frameworks and the data JPAs and all those things. It's
That's
just
true.
even they made the complicated RDBMS application glue code into a very simple way, because these are already, again, they learn from these experiences and again they have abstracted it.
That's true. Yeah. And you're right. Like it is a lot simpler now to use things like Java Spring to, you know, write like simple insertions. So it is a little bit more, you know, elegant in terms of like not having to worry about like how that data gets translated from, you know, what it is in Java Spring to like the database using ORM. So, and then returning that data back, it's all just objects. It looks more like programming. I don't know, Amelia, were you talking?
Yeah, so I had a question. So basically you said the ORM kind of hides the complexity, right?
Mhm.
So what exactly is the ORM solving? It's basically mapping the object definition in your application to a table, right? To the table as table schema. So basically you, it will take care of any incorrect writes that you're trying to push through your application, because you know what the underlying layer needs, and it probably will, it makes it a compilation error instead of a runtime error. Is that what it does?
Yeah, as much as possible, it does that. If it finds, because you know these are already if because schema is already there. So as long as you have a schema, we can make it as a compilation error. But if it is a data, then it will go to the runtime error, right? And that's not only that, ORM also hides this complexity of joins, right? In Spring Boot, Spring JPA, now you have annotations. Earlier, at least, we used to link that with a lot of glue code, but even with annotations also, even that bootstrapping code is also completely abstracted, like multiple joins, lazy loading, caching, and if you have a transaction where it requires multiple, multiple reads and writes, it hides that and give us from a more application programming view. You can think everything as an object, but it also has, I mean, if it's really a complicated application, there are challenges as well, right? So then what developers do is they go deep into the ORM framework itself, right? Because ORM framework is a very generalized one, right? But if you have a very specific use case, you can even optimize that ORM framework. Or no, for some use cases, it's too much for you to optimize ORM frameworks, right? Even the application frameworks like Spring JPA, what the Data JPA, what they do is you can write directly a SQL query because some of the things they overcomplicate using the frameworks. But these problems, some of them you can directly write a single query and you can get the data if you're using a SQL query. But even in these frameworks, they provide, you can just directly write, if it is complicated to deal with ORM frameworks, you can directly write a query within your application code.
That would be the stored proc, right? And which is not recommended.
Not store proc, with a simple complex query also. Sometimes it's very difficult to convert that into an ORM kind of relationship. But where that developers, what they do is they'll write the SQL native query where application program itself can execute on behalf of on a client. Store proc, yes, you're right. People are not using store procedure nowadays because they want to do the business logic and the application side.
Right. So the ORM also handles the join complexity, like
it hides that, yeah.
It hides that. Okay. I have not used
as long as you design your entities properly on your application side, then it can deal with the join complexities as well. But of course, we have to configure them.
Properly. It's called Hibernate. Is that correct?
Hibernate, yeah. Hibernate. On top of Hibernate also, Spring Frameworks has a Spring Data framework on top of Hibernate. It leverages Hibernate, but if there are on top of that, it provides, it simplifies more on top of Hibernate, Spring Data.
Yeah, I agree to a lot of points, but
complexity right here.
Still the maturity on ORM is not what it's really designed for in the get-go. A single application with a single tenant, ORM is great. With multi-tenancy, ORM is not great, right? It depends on the complexity of the application itself. Simple CRUD, yes, it's great. It encapsulates a lot of things and like makes it easy for you to read and write data. But think of it in a multi-tenanted mode, it doesn't provide as much flexibility even today for you be able to use the ORM from the code base. So there are plus and minus.
I agree.
So can you elaborate what is multi-tenant model?
Think of it this way, right, Amulya? Like, for example, you're building Chime, right? Chime is dynamic service, right? Even if at the API level, different users or different enterprises can come and register themselves, whereby you're like separating the database for each enterprise customer, right? Okay, customer ABC has its own database, customer XYZ has their own database. So this is like truly multi-tenancy, where you store each customer's data in a different database itself. It could be the same bigger umbrella database, could be MySQL, Oracle, but like you have separate schemas, right? Dynamic schema creation, when they register, dynamic, allocation of, those resources, a single shared API, which is like shared across different enterprise customers. So, this whole dynamicity is much easier when we handle it directly without ORM than ORM, right? You build patterns, all the niceties of J2EE, you build around it, and then you can use it because it brings the power for you to be able to manipulate everything. ORM, you need to have specific configuration, so it doesn't have capability to context switch based on each customer to go look up its own database on the fly. right? If you have the 5 customers, you go provision 5 databases, you can probably have configuration pointing to 5 different databases, right? That way it's fine. But if you want to do everything dynamically in a multi-tenanted mode, right? Truly, if you want to build a SaaS application of sorts.
Like Bitbucket, I'm not sure if you guys know, the recent downtime of Bitbucket was more than 2 weeks. They had this multi-tenancy. They didn't separate the database to a single database, and they were maintaining this multi-tenancy architecture in the single database. So it was
that's one way to do it. Yeah, one way to do it is like you separate it based on the customer ID and stuff like that. But there are some, governance and laws in some other countries, right? When you go global, Europe, they don't allow you to do that. It needs to be separate database per customer. But ideal architecture is always separate database per customer data, right? So that there's no mixing and there are many use cases where people have built on a single database, multi-tenanted data, right? Separating by user ID and stuff. And sometimes it's been exposed outside by some mistakes or bugs, right? So one way to avoid it.
Amazon has a good white paper on multi-tenancy.
Oh, cool. Would you be able to share it? Yeah.
Yes. I need to look at my archive, but yeah, they have it. That was really
throwing in an article here to help us kind of cement this, because multi-tenancy, I just kind of did a search and I found this Wired article about issues with it. So this might help us understand this topic a little bit better. But yeah, great discussion so far. I really love it. I think this is going pretty well. So, I think just kind of in general, right, we're still talking about which one do you use? Like, do you use document or do you use relational? And here we're just kind of like we're talking about the limitations of document, but our discussion kind of started towards like, issues with the other side too, like using entities and Hibernate and translations across using ORM, making it difficult to work with data on that side. But we also talked about abstractions and how Java Spring makes it easier for you to like not think about writing so much SQL, which is a good thing. I think that's important. You want to feel like you're writing more towards like programming. Like if you're working in Java Spring, you want to feel like you're writing in Java the entire time. I think that's kind of a nice feature of Java Spring. So just basically here, if your application does use many-to-many relationships, documents are less appealing. And, the thing about documents is that they're denormalized, which basically just means like, they're not, I guess like normalization and denormalization. Like I always kind of, like I kind of remember this, and then there are periods where I don't, but I think like essentially, just normalization is like consistent across, tables. Let me see here. Let me get a real definition for it. Or does anybody want to jump into it?
Another point to add, right? Like one is the data and the relationship with the data. Another big factor that drives between SQL and NoSQL is, are they read heavy, write heavy applications?
Right.
Think of it this way, like where a particular device is like, or for that matter, like thermostats like Nest or whatever, right? They're constantly pinging and sending information from the device. So these are like write-heavy applications, right? Mm-hmm. You get like better performance data on a NoSQL for write-heavy applications than RDBMS. When there is read-heavy applications, like you're constantly, for example, like what Amelia mentioned, constantly querying a particular profile detail, right? Or users are constantly doing that. Those RDBMS fits those profiles better, right? At times, right? Not that I'm not saying NoSQL will not. It depends on type of NoSQL. In this case, I wouldn't fit DynamoDB to be a NoSQL. It is a little bit advanced on the NoSQL area as well. It is both columnar and row-based kind of a database. So it deserves its own area, but I don't know what to say that. But yeah, a general rule of thumb is you always look into it. If read-heavy applications, you try to gravitate towards RDBMS because one, like you guys mentioned, the SQL execution query plan, which can be tuned, tweaked with indexes and stuff. And it, believe it or not, RDBMS has its own cache as well, right? LRU, where often when the same queries are run again and again, generally it's those query execution plans are cached as well. So it brings some milliseconds performance than queries which are not used often. Something to consider as well as part of the whole equation.
Right, but then they say in the document, I think one of the strong points for selling points for the document-based DBs is that they take advantage of locality, right? So that is
yeah, absolutely. I'm not saying that, but general rule of thumb, I'm saying like read-heavy applications versus write. That is also one of the factors. Locality is now again it's purely based on the CAP theorem, right? NoSQLs have mastered that. Like either you are a CP system or an AP system, right? In the consistency, availability, and the partition tolerance. So the locality part you're talking about is the partition tolerance across regions and stuff. You know, the reason why they are like, you know, some of the systems are CP based and some of the AP is like you can never match all the three in a distributed
I think
system.
Karthik, I think she's talking about the locality of documents itself, not the. I think is that what, Amulya? When you say a locality, because where you all the in a document DB, a document is located at one place, unlike in relational where tables might be spread across different memory locations.
That's actually okay. So like coming back to normalization versus denormalization. Now, like denormalization is essentially like you make everything like in one document, right? So that it has better locality. And then the normalization is like when you move things into like different tables because you want to like reduce like complexity of one table. You want to like kind of use a key to keep everything together, kind of like the LinkedIn example. So and I just kind of picked it up here because when I hear about normalization and denormalization, sometimes like my brain is like thinking like what is this normal versus denormal thing? But
wrong.
But yeah, just think divide, right? Like when you hear normalization, you're dividing the data into multiple tables, and then denormalization is like combining data so it has better retrieval, which I think plays into the locality. So this is pretty helpful if we're talking about this statement here.
It's like, I can give an example for normalization and denormalization, right? Where like, you know, if you have the same field in multiple tables, right? This is the data redundancy. You don't need to maintain for like you have a string, right? And you have that string value in multiple tables. So rather than that, you store that string once and create an ID for that. So you are saving space. So that's kind of a normalization. And when it requires, then when you're doing a query, it denormalizes and do that. And even in normalization, also they have first normalization, second normalization, third normalization. There are techniques where you design. It's a database design as well.
Good stuff. Good discussion all around. Okay, so let's see here. I think just this last part here, basically it says that, you know, if you have a many-to-many relationship and you want to do joins in general are kind of like slow. And if you're trying to do a join on a document, it can be even slower, you know, because application code may be clunky and not as good as like your, you know, optimizer that you might have in SQL. So if you have a lot of complex data, I think this is a classic question. Should we do this on the front end or the back end? And I think like if you have complex data models that you need to work with, it definitely needs to go to the back end. You know, if it's simpler data, like you're just working with simple JSON, then sure, it can be done on the front end. I think that makes sense. So we're kind of like almost going to talk about graph models, which are coming up soon here. Let's see.
One point I want to bring up is denormalization is a kind of a risky thing because So the main, so yeah, the obvious advantage is that you get the space saving, right? The data is not unnecessarily bloated. But the other thing is updating, right? Like if you decide to update a field,
Yeah.
kind of it's really painful in document DBs to kind of keep the data consistent. If at all you have to incorporate a change, now you have to write a worker or a background async worker to kind of synchronize the data according to the change you're making. So it's really it's a cost that you should be aware of when you are that's the
Data.
way for the locality advantage.
Yeah, for sure. Okay, and Karthik, do you have your hand up? I wasn't sure. I think it's just on. You might have forgotten to turn it off. Okay, so kind of let's see here. The next section here is just flexibility in the document model. Again, it says JSON does not enforce schema. Let's see here. No schema means arbitrary keys and values can be added to a document, which we kind of already talked about. And then basically this section here is that document databases are sometimes called schemaless. The code reads the data, usually assumes some kind of structure, right? An implicit schema, but it's not enforced by the database. So it isn't really like when they say schemaless, they don't really mean that there is no schema at all, but it's just not enforced. It's schema on read, and then interpreted when the data is read. Whereas there's also schema on write, where in the traditional sense of a database, your schema has to be explicit and the database has to be, the ACID compliant. So written data is conforming to, that, again, like the requirements that, relationships have. So, so he says schema on read is similar to dynamic runtime checking in programming languages, whereas schema on write is similar to static type checking. So like, again, Java is kind of like one of those, static compile type checking. You have heavy type checks in like the programming language. So that makes sense for schema on write. And then schema on read, it's just more like, a runtime language like JavaScript or something like that. So that's probably why like NoSQL is probably written in that JavaScript syntax. But ultimately he says, there's really no right or wrong answer about like which approach is better. You just have to pick one and go with it. Then he gives some examples here about like how, you write in like a dynamic way, right? This run type approach, like JavaScript approach. So user.firstName is equal to user.name.split, and then a split on the string, a blank string, and then retrieve the first index. So put whatever's here at this first index into this user first name, right? Or you can use database schema, which looks more like, this SQL syntax, English syntax, and it says alter table users, and then add a column first name with field of text. And so you see the type here, right? Like they were saying, static compile type, update user set first name equals split part name. And then one, this is a PostgreSQL call, or this is how you would do it in MySQL. And like you all were saying earlier, like if you try to change the schema later, that's not going to be kind of difficult to work with for, SQL, where it's not as difficult with something like a document database. So, it says most relational, even though like it's slow, he kind of says like, there's an example here, like when you try to alter a table, even though it's slow, it can be done in like a couple milliseconds. But if it has to do like an entire copy alter table, then that means like you can have minutes or even hours of downtime when altering a large table. In fact, this is worth a highlight here. So
I think what he's saying is MySQL is an exception for alter, but other databases like Oracle and SQL can handle alter table within few milliseconds. MySQL doesn't have that capability because of the said reason.
Yeah, so basically you, with the document DBs, right, you completely skip that step. You can just start writing to that column.
Yeah.
So, but like here, so what does alter table do? Does it make a copy and like deprecate the old one, or what does it do? Like it just adds a new column. And
but before that, right, I want to ask you in document, how do you do that? For example, you have like thousands of documents, right? And you want to add one field in each and every document. So you read all those documents and write again. Is that correct?
Yeah, that's called backfill. So basically, if you add a new column and that is needed for all the existing existing records to have that column, then yeah, you have to do the work of actually going back to each record and populating it. But usually that's not what happens. So you add a new column to support a new feature or something. So so you have a default value that you want to assume for that column. So when the record is read and you see that that column is not set, you set it then. That's what is the example we're talking about. So
and you write it back, right, in documentation.
You write it back. It's a it's a risky thing, like, because like if you're doing a get API, right, you don't expect the record to be updated in a get API flow, right? So that's kind of coarse mill, but that's what we like that's the norm. So yeah.
In SQL, I think what they're saying is like in document DB, you do that kind of changes on the application side and write those changes again. But in SQL, you don't need to do that kind of changes on the application side, because the SQL on the server side itself can make those alterations, especially for the alter. For example, they have a full name field and they want to create 2 more columns, first name and last name, from that full name. So you write a query. You don't need to it's a one-time change. You write a query on the database side once, and it will alter the tables. It will alter the entire table.
But like, is the table not available for writing during that time?
No, it is. I mean, if these changes are only one time, right? These are not dynamic changes. If you look at it,
no, I'm saying
you can
when you are making this change, right? You are doing this alter table. You are running this alter table thing.
Yeah, you might be right. I think you're right.
Is the table not available for writes? Like, let's say application is also writing and this thing is also writing, then you run into issues, right?
That's what.
Yes, of course. Yeah, they're locked. Yeah, it will not commit until there will be a lock if you're writing at the same time. If the application is writing and you're also altering is also indirectly writing, right? It will lock. That's what the the immediate consistency which gives the relationals, right, ACID properties. So it will hold until that original write completes. Then you can make an alter write on the SQL.
No, the reason I ask is because it's making a structural change, not writing to a record. I can understand that if there is a write conflict, then you kind of wait, and then there are other ways to solve that conflict. But if the table structure is changing, right, then
still you have to wait, because if you look at it, right, write is updating the data in a predefined structure, but with alter you're changing a structure.
Yeah.
Not only changing a structure, you're reading the data as well, right? Because you have to read the full name first to divide that into, split into first name and last name. Now, by the time while you're reading and you read the data in alter table, first it will read that full name. But if the application writes that and change that full name, then you lose the consistency. So that's why if alter is happening first, then it will lock the table. Then it will hold the write. If write is happening first, it will hold alter, let the write completes. Once it is committed, then alter will execute. It's a both. Alter is both structuring and as well as changing the data as well, or adding new data. It's a two actually. It's both schema change and as well as write.
I think like the point here is too, right? Like it's simpler to just update a field with documents, right? Because like here we're just getting the first name from like splitting this name, right? We're just saying, okay, want to split like on the first time we see like a, you know, a space. And so we're saying, okay, that's the first name, just throw it into this field, but we don't care about any other documents that don't have this first name field. We're just going to, you know, alter this and it's a one and done kind of thing. Whereas here, when you're doing the same exact operation, now you've got to alter the table and you've got to wait for all the fields, you know, to update because of that strong schema.
But,
So you can see.
I don't agree. You can do even in SQL as well, right? You don't need to do a structural change. If in document DB, they're not making any structural change because they know it's one of the use case. They're doing it on the application side. Even in SQL also, you don't need to do a structural change. On the client side in the ORM, you read a full name and create a JSON object or a Java object and split it using string manipulation operations. I think just to highlight how this structure is doing that, but in this particular case, you don't need to do a structural change as well.
No, yeah, that's there, but then you are losing the benefit of relational thing, right? So I mean, if you put it as a blob, then you can't really make easy queries. I mean, your queries.
If there is, yeah, you're right. You have to make a structural change if another table is also dependent on first name or last name. That might be the case even in document DB as well, right?
Yeah, and I think this is actually a real world problem, right? Like when, you know, you have some kind of backend backed by SQL or MySQL, which is pretty popular if you use PHP, you know, just doing like this change, like, oh, we're not going to have like a full name anymore. We're going to have first name and last names. You have to kind of go and like manipulate that data really quickly, or you have to go back into tables and redo everything. So whereas like if it was a JSON document, it's just pretty straightforward and just like add the extra field, you know. Although you could say it's time consuming there too as well. Did you have something to say, Ramya?
Yeah, I had a follow-up question on the point which Amulya got up, right? When you're doing a get writing, having a write is some kind of an anti-pattern and it will probably not good. You have to block until the previous writes are finished. So for write, it's okay. If there is some deletion or happening on any of the fields, then the application code reading that structure in future will error out, right? Some kind of backward compatibility is lost. Are these, so when doing a write or do we explicitly have, or this database have explicitly have checks to prevent the user from accidentally deleting stuff?
No, that
deleting a column.
That is a point. That's on the developer to make sure. So there are best practices. The way if you want to delete something, right? So there's actually a runbook kind of a thing that you have to follow. Like you first remove all the reads to that basically in your application kind of. Yeah, it's kind of you do the due diligence of stop using that. Remove all the references, deploy, and then deploy that code, and then you do this remove the writes, and then deploy that change, and then remove the column. So
in big banks, right? Delete operation itself, in big banks, right? Delete because you know the way you access the SQL DB is using connection string, and you have a service account, right? They don't even give permission for you. The developers, whatever the application credentials that you have to access the SQL server, that credential doesn't even have access to delete. It's just write and read. That's it. Or updates. You cannot delete it. They don't even give you access. If there is a delete use case, then there will be a run of a separate governance team or a separate job that will be run. Before they don't never do hard deletes. It's all soft deletes. They delete it, but they store in another table called a delete table to preserve the records, depending upon the compliances that you have, whether it's HIPAA or whether it's PCI and all those compliances.
No, it's not about deleting the record. It's about deleting a column.
Even they're both deleting a record or a column. They do not give authorization for us. Developers doesn't have the ability to delete programmatically or manually.
So you have to essentially update your code, right? If your code was accessing that column, then the code becomes not compatible to the existing.
Correct. Or it will fail.
DB itself does not guarantee anything because it's schema-less, right? It is supposed to provide that is a service it's providing. No, but
Yeah,
the question, the quick question for SQL users. So what is alter table? Is that written as a separate, operational thing that like you want to add a column? So you first run this operation on the table to accept this column, and then you go update the code to use that column? Or can you kind of do it dynamically as the application is running? How do you do this?
Generally, right, if these changes are part of a business use case, right, like they are real-time use cases, you have to do alter table kind of changes. We consider these are schema changes. During the deployment, we do it. That's it. This is not a real-time use case for every application, for every user. We need to make these changes. This is a one-time. We call it as a schema or a configuration change. Do it at a once before deployment or a bad job that we do it.
What are the risks? Like what can go wrong here when you do this? Like
this is, yeah, I would say this is a safer option. Alter table is a safer option, again depending upon what type. For example, this first name and last name, right, or full name, right? You're not making changes to the existing data. Actually, you are adding new columns and you are adding new data. That's it. You're not making any updates to the existing data. So the risk is very less here in this alter use case. But whereas update, they're very slow because you have to update the entire table, right? That means each and every record. So obviously there is a risk. If you have to keep the record. Again, you have to think about cap theorem. You also have to think about if the database is not available during your updates, how long it takes, and how many customers you have. Yeah, there are other operational aspects that you can think of during updates. But alter is in this use case is a much safer option.
Got it. So there is
and also it depends on the concurrency, like Srini mentioned, depends on how much data is there. So the risk of altering a table if it has way too much data, right? So the minute alter is issued, the whole table gets logged, number one. So it's not open for any transactions at all except reads, which is okay. But it again re-indexes everything. So imagine you have like over 1 million or 2 million row sets, right? The minute alter is issued, it again scans through the whole data set and does the indexing of whatever indexes you have defined. So sometimes it can take longer, right? That's why these operations, they have scheduled outages. They say, okay, based on like when they test this out in pre-prod or staging before with a similar data set, with a similar kind of a replica strategy, they make an assumption, okay, this is a plus or minus timing. So they give an outage. And those changes are done on an outage level, and quickly the application code referencing this change will also get deployed so that there is no issues, right? And then they'll slowly backfill the data. And then finally a different stage where again outage would be issued where you delete those older referenced column and then redeploy the application together as a package.
Yeah, that's painful.
Yeah. And so I think that kind of like ties everything together. Like this helps with that discussion, which is better, but feel free to try this on your own too. I mean, if you want to play around with some, like a quick sandbox of JSON and then also a sandbox of SQL, kind of time it.
This is you get from experience, because on a development sandbox, you don't have that much data, right?
True. And I was about to add to my statement. I mean, if you want to like try doing lots and lots of records, see how it works, right? Like that would be part of the test. Like, don't just do like, like a couple, like 20 or something like that and say, oh, I'm done. Like really look for something with a lot of like data.
If you want to replicate this locally, preferably not on a single instance, right? Minimum 3 node clusters, you need to bring it up. That's when you'll see the true issue coming up, real issue, right? You can probably get away with 1 million record sets, even updating in a local single database, to be honest.
Srini, do you agree with what Karthik said? Like that's the problem I was trying to point to earlier. Like this operation incurs an outage on the service.
That is true. I mean, if the data is huge, right? Again, I missed the last point. Are you talking about when Karthik made a comment about if the data is huge during the alter table commit, it has to log the table?
Yeah, any schema change, right? Like it has implications on, first of all, the load that basically the right load that the system is taking, and then also updating the indices. So all that means that your service is not talking to a healthy database, right?
That you are right. There are two things, right? One is if you have an index and your data change is not impacting that index, so there will be, you don't need to do a reindex,
Okay.
right?
Okay.
I'm thinking that, correct me if I'm wrong, but if your data change is impacting the index, yes, obviously you have to reindex them because memory locations will change, right? And yes, if the data is huge and you do, again, you do these kind of huge changes during the downtime, or you don't have enough downtime because it's write heavy and read heavy, then you properly do the change. Or what you do is, because for example, you have this use case. Let's take this particular use case, right? It requires this particular use case. You need it in maybe down the line after 2 to 3 months. What they might do is they might do maybe weekly change to alter subset of data until it goes the actual use case, right? So that they don't need to have this big one downtime. So you can do the changes in the batches. And then once the changes is done before the release time, they do some testing before it releases to the actual application.
So you can do that with SQL. You can update a set of records to have a column and not the rest.
I mean, column change is a table-wide change, but splitting the data and adding the data to the new columns, right? You can do that.
Oh, yeah. That's fine. Yeah. Okay. That makes sense.
Okay, it is 8:38 here. I guess we can come to a stop. This was a good discussion though, I think, like in general about NoSQL versus SQL. So I think does this kind of like help with that question? Like I guess that we might have had in the WhatsApp and also on Discord. I think we're at a good place to move to the next part of the chapter. And I guess this is probably going to like talk about locality. So I suggest like maybe just kind of rereading again if it's been a while since you've read like the chapter. And then we'll get into query languages, which I thought was kind of like a little bit fun, kind of like how you can make these declarative queries if, in contrast to imperative queries. And they go into stuff like CSS and how CSS is also kind of declarative and it's easier to use as a result. So I felt like that was a really cool part of the chapter. Yeah, thank you all for coming. And I hope to see you both on the Discord and the WhatsApp and all that.
Thank you. Bye.
All right. See you next week, Wednesday.
Thank you.
Mm-hmm.